My name is bbitzer. This is my senior project, the pressure washer broom, and this is my project presentation as well as my demo video. So let's get started. The problem faced. In the off-roading world, trucks, lifted vehicles, Jeeps, Toyotas, ORVs, your Can-Ams, your Polarises, they get dirty and covered in mud. Washing the outside of the vehicle is super easy. Just get a bucket of soap, get some water. However, what a lot of people seem to miss, and what is even more important than washing the outside of the vehicle, is the undercarriage of the vehicle. This contains suspension components, brake lines, fuel lines, ball joints, rubber bushings that need to be greased, and without proper maintenance can wear prematurely and things can break. Proper maintenance is get rid of that dirty water, that mud, anything that's underneath there, and putting clean, fresh water to it so that everything is nice, shiny, and without any issues. This is critical. Traditional methods for washing the underside of a vehicle require crawling underneath your truck, covering yourself in muddy water, getting even dirtier than the vehicle was to begin with, and missing spots because you just want to get the hell out of there. A pressure washer broom can solve all of these issues. Pictured to the right is my father underneath a vehicle, washing with using traditional methods, which just isn't enjoyable. Some of my project objectives were to design and build a state-of-the-art, efficient, and inexpensive undercarriage washing device that is more user-friendly and efficient than current pressure washer capabilities. I wanted to effectively create a time study so I could wash the undercarriage of a vehicle with more effectiveness and speed than traditional pressure washer methods. And then the biggest objective was to use the skills accumulated and show that I have learned something and learned an incredible amount in the degree of engineering and in my field of study, as well as create a working model. To once again state my problem solution is to create a tool to wash the undercarriage without the need to crawl underneath the vehicle. A pressure washer broom presents the best method for washing the undercarriages, and hopefully, as we see, it very well is faster than traditional methods. The pressure washer broom is a 17-inch aluminum attachment for a pressure washer featuring 5 evenly spaced tips that are 1/4 inch female to 1/4 inch male, 1/4 inch male removable, so that different pressure washer tips can be accepted and used. Pictured to the right is the pressure washer broom in action. I was using a couple 40-degree tips and one 25-degree tip. You can use any combination of tips. I found that 25-degree tips work the best for just general light washing. I wanted to find some internals that were 1/2 inch piping and could withstand a 2,500 PSI requirement. That number came from the strength of the pressure washer. That's just the baseline minimum. Of course, the stainless steel that would be used has a much higher requirement than that and has a much higher break point. It features a wheel on either side so that it's easy to move underneath the vehicle with ease. I had 2 primary deliverables, the first being a successfully working broom. Working, in my mind, was something that wouldn't break the second I applied pressure, something that I could test and prove worked, and something that after a couple hours of rigorous testing would continue to work and that I can actually use to wash my Jeep or wash my truck as the years go by, as well as even upgrade the pressure washer broom to something newer or more efficient. Secondly, I wanted a pressure washer broom that was faster than traditional methods. And what I mean by faster is more effective in washing the underside of a vehicle. So something that I could stand outside my truck and simply roll underneath a couple times and get a nice clean wash so that I can stay dry, so that I don't have to spend hours washing my truck, and I can just get back out and hit the trails once my Jeep is clean or once my truck is clean, just to rinse and repeat and wash again. Because that's half the fun, is cleaning up after the mess. There was a lot of skills used throughout this entire project. The 4 biggest are noted on this slide. Tech 3041, Strength of Materials. I used this course to determine what material I needed for my internal pipe, as well as my external case. I settled on Schedule 40 T304 stainless steel. The reason I chose this type of stainless steel is for how common it is, as well as the ease of use with cutting and drilling into it. The outer shell is 6063 aluminum. This aluminum is easy to weld since I had to weld my end caps on, as well as good corrosion resistance. Since this is entirely based using water pressure and using water, water creates rust. I didn't want to use anything that would rust up and look bad, and I didn't want something that would oxidize. So I chose this aluminum primarily based on its corrosion resistance, as well as the ability to weld on it fairly easily. Tech 3421 Manufacturing Processes 2. This course taught me the skills I needed to cut, tap, thread, drill all of my holes, all of my ends, all of my fittings. I had to use the lathe on some end caps. A lot of time was spent in the engineering lab, as pictured to the right here, just cutting and milling holes and getting everything set up and making sure everything was perfect. Tech 4472 Computer Aided Design. This class was crucial to the actual design of my project. Everything I designed was in NX, every piece, every part. And when I had initially created design, so last semester during project proposal, I was still in this course. So it was interesting to be in the class while learning the application, while trying to use the application to finish my senior project proposal. But that was just another challenge that I overcame. And it was really kind of rewarding to see when I had to redesign this semester a couple things that I could just pull up NX and I knew exactly what I was doing, knew exactly where I was going, and I was able to just knock it out real quick. So an NX is just actually really fun application to use, and I can't wait to use it in the future. Tech 4460 Work Design. This is where I came up with how to create a time study and how to actually go out and make the Excel sheet to create my time study. So this class was crucial to creating the end result of my project. For testing and design purposes, for the senior project pictured to the right and that what is turned in, I used cold rolled steel for the internal pipe. Everything else, of course, is going to stay the same, from the aluminum to the wheels to the pressure tips. I used cold rolled steel mainly because it was fairly cheap and fairly inexpensive to use, just because there's no point to get the stainless steel right now, just for a one-time test. However, I could always take this apart and upgrade to stainless steel if I needed to, and I more than likely will, so I can have a longer lasting product. However, in a real world setting, full production, stainless steel will be used. Once again, that's a T304 stainless. This is a quick product demonstration, as well as my demo video at the end. So what we have, once again, are the 5 quick connect female tips, as well as the inlet. The inlet is positioned in between 2 of the outlets, because if I had it butted right up against the outlet hole, the 2 threaded holes would line up with each other perfectly, and I would lose the entire structural integrity of the case. I have a 25-degree green tip, a 40-degree white tip, a 0-degree red tip, and a 15-degree yellow tip, and finally a soap tip. Each of these tips can be used all green, all white, all red, or they can be used interchangeably. Once again, I found the 25-degree green tip to be the best fit. You simply pull the outer case down, slide the tip in, slide the casing quick release back up, and your tips are in. When you're ready to pressure wash, you take your female end on your pressure washer, connect it to your male tip on your pressure washer broom, and now you're ready to pressure wash. This is a quick demo video washing underneath the underside of Ram 2500. So a full-size pickup truck, 4-door, full bed. It worked very well, did everything that I expected to do. As you can see, it's a little short on the wand length. However, in full production, a wand extension would be sold with it for ease of use, so that you can easily, even easier, reach underneath the vehicle and pressure wash. Getting down to my effectiveness, for traditional methods, the setup time was 53.8 seconds. For the pressure washer broom, it was 65 seconds. So the pressure washer broom was a little bit slower compared to traditional means. However, The reason it was so slow is because I was setting up from no tips inserted. If you were to say you were using 5 green tips, set every single one of your green tips in there, put it in your garage or put it in your barn, and walk away until the next time you come back out, and all you have to do is hook it up, you could shave off roughly 9 seconds of trying to set up each tip. So then you can just get straight into pressure washing. So you're a little bit closer to that 53.8, so a little bit closer to that traditional time. However, the real advantage and the real effectiveness that I was trying to prove and that I ended up proving was total wash time. So the total wash time of the pressure washer broom was roughly 96.8 seconds, while the traditional was 217 seconds. So the pressure washer broom proved to be roughly exactly 45% more effective. This is my workflow and cost, and time management was the biggest thing that I had learned from this course. There was a lot of times throughout my workflow that I had to readjust just due to having to balance senior project with other classes as well as ROTC. But I did it, I adapted, overcame, as we all should. To produce 1 unit, it will cost roughly $111.74. This is a little high. Of course, that cost can be cut down a little bit if I were to order more in bulk and maybe find a different company that I could order from. So there's 4 major lessons that I had learned from the senior project other than time management, time management, time management. The first being measure twice, cut once. I had bought enough aluminum to make 2 pressure washer brooms just in case I would mess up, and I messed up. So I had to redo my aluminum case, which was okay, but I lost time. And in a real world setup, in a real world production setting, that would cost the company money, that would cost the company time, and nobody wants that for their business. Secondly, putting the design into the practical doesn't always go smoothly. Give plenty of lead time. What that means is when I designed an NX, everything was computer generated, all the holes were smooth, perfect spacing, perfect size, perfect diameter, perfect. In the practical, not so much. Human error was involved. So when I was cutting, a couple holes were off. So that kind of, once again, builds onto that measure twice, cut once aspect. Thirdly, order parts early. Unexpected weather can delay a project. We had a pretty rough winter. We had plenty of snow that delayed a bunch of my parts coming in, which set my senior project back about 2 weeks. Had I ordered the parts earlier, I could have been done, or I could have been focusing my efforts into this presentation, into my final project, which isn't to say that I didn't do well on either one of those aspects, but more time could have been spent on those, or more time could have been spent making sure that my senior project practical was smooth and perfect. Fourthly, order the right parts. I had ordered, for my quick connects, I ordered air water fittings initially. Turns out they were just air fittings, which luckily Granger, the company that I ordered them from, has a location here in Memphis. So it only took about a couple days to get the right parts ordered. However, in a real world mass order production, if I was ordering 1,000 quick connects and they all came in and turned out to be the wrong parts, that could cost weeks of trying to find the right parts and get the right parts ordered, as well as costing the company hundreds of thousands of dollars, which once again decreases that lead time and decreases the effectiveness of the company. Finally, things I'd change. As much as I like my round tube design and as much as sleek as it looks, a solid block with just a through hole and 6 holes drilled into it would be a lot more efficient and could be something as like a second generation. However, it'd be a little bit heavier, but it would be, you could take massive amounts of pressure through that, as well as it wouldn't cost as much and wouldn't take as much time to mass produce. I'm now going to open up to any questions. I realize this is a virtual setting, but I'm happy to answer any questions via email, via phone call about the senior project and about this presentation. To wrap things up, my senior project was the pressure washer broom. I wanted to design something with 5 evenly spaced tips that could wash the underside of a vehicle more effectively and more efficiently. Based on this presentation, I have done just that. I have a working model that is 45% more effective than traditional methods. I have used every single class in my field of study to the best of its ability and to the best of my ability to produce this project. I'm incredibly proud of what I've done. I'm incredibly proud to be a part of the engineering technology community. And I look forward to graduating and using these skills in my naval career as a naval officer. Thank you all once again for taking the time to watch this presentation. Good day. These are my sources.